Hey guys, Mr. Yisley here. So we're on to lesson number 5 in chapter 2b, which is all about solving linear inequalities. And so in lesson number 5, we're going to start talking specifically about how to solve inequalities. And so within this, we've got kind of a 3-step approach that we're going to go through to solve these inequalities. Our first step in that is we need to find our variable and figure out what's being done to it. Right, this is really similar to the exact same method that we followed when we were solving linear equations. You've got to find that variable, figure out what's going on with it. Is it being added, subtracted? Is something multiplying it? Is something dividing it? All of that stuff that we look for. So that's our first step. Our second step is we're going to reverse that operation, right? So we're going to use inverse operations. And we're going to undo that. Now this is where we talked about creating that to-do and undo list, which I'm going to strongly encourage again, because as we saw on our assignments in the previous part of the chapter, or in chapter 2, those of us who are doing to-do and undo lists were doing significantly better, more consistently, because we knew exactly what was happening and what we needed to do in the order that it needed to happen as well. And then once we've got that figured out, we're going to go in and we're going to actually do that and solve the inequality. Now our goal within this, right, is still the same. We want to get the variable on one side of the inequality symbol and the number on the other. So it should look really similar to the linear equations. So in those we had like x equals 3 or x equals -5, something along those lines. Well, instead of having an equal sign in the middle between the variable and the number, we're going to have the inequality symbol. So that's really our process that we're going to follow. And so this will be used consistently when we're solving linear inequalities. So we're going to go through those 3 steps consistently. All right, well, let's take a look at 3 examples then, and we're going to start with some addition examples. So I've got example A here, says x minus 6 is greater than or equal to -10. So again, first thing I want to do, find my variable and figure out what's being done to it. So in this case, I see that I have an x right here on the left side of the inequality symbol, and it is being subtracted by 6. So if I were to go in and figure out what I need to do to solve this, the first thing I'd want to do, come out here and create my to-do to undo. And I would say, all right, they are subtracting 6 from x. Well, I need to do the inverse operation. So to solve, instead of subtracting 6, I'm going to add 6. And just like with linear equations, whatever we do to one side of the inequality, we also have to do to the other to keep it in balance. So that would be my steps to solve. So now I need to go in step 3, I need to actually solve the inequality. So I'm going to add 6, as I said right here, on both sides. So underneath where they were subtracting 6, I'm going to add 6. And then underneath the -10, I'm going to add 6. Now when I do that, I know that -6 and +6, those cancel out as they did before. And I'm left with just x on this side of the inequality symbol. Then I'm going to bring the inequality symbol down exactly as it is, so greater than or equal to, and then I'm going to do this, -10 plus 6. Well, 10 bad guys, 6 good guys show up, they battle, the bad guys are going to win because they have more, so I'm going to end up with negatives, and they have 4 more bad guys. So my end result of my simplified inequality is x is greater than or equal to -4. Now with each one of these examples, they also want us to go in and they want us to graph that. So we learned all about that in a previous lesson, how to graph. So the first thing I want to do is I want to label my graph. Well, I think the easiest thing to do when labeling this graph is to start with numbers that the number they gave us. So right in the middle, I'm going to put -4. And then I'm going to skip every other dash and I'm going to count by 2s. So going upwards, this would be -2, -1, 0, and then 1, 2. And then I'm going to do a few numbers to the left of -4. So that would be -5, -6, -7, -8, -9, -10. And so there we go. So now I've got my numbers here. So the next thing I want to do is I want to pick a number to the left of -4 and then I want to pick a number to the right, and I'm going to plug them in to see which one makes it true. So on the left of -4, I've got -6, because remember, number lines always get less moving to the left and greater moving to the right. So I'm going to choose the number -6, and I'm going to plug it in for x and see if it comes true. So I've got -6 is greater than or equal to -4. Well, is that true? No, that's not true. That is false. So that means that moving towards the left, it should be false, which means it should have an arrow going towards the right, as we learned. But let's choose a number to the right and see if that makes it true. So I choose the number -2, and I'm going to plug that in. So I got -2 is greater than or equal to -4. Well, is that true? Is -2 greater than -4? It is. It's not equal to, but it is greater than. So that made this true. So my arrows should be going towards the right. So then I need to go back to the original number that we figured out, which was x is greater than or equal to -4, and I'm going to put my circle at -4. Then I need to check, do I have a portion of an equal sign? I do, which means that this circle is filled in. And then last thing, I need an arrow going towards the true solutions, which was on the right side here. So this would have an arrow going that way. So that would be how we solve this linear inequality and then how we graph our answer, because everything starting with -4 is at least equal to -4 and then or greater than. So everything moving in this direction would be correct or would be a solution. All right, well, let's take a look at example B. If you believe you can do that one on your own, then I'd encourage you to try it on your own, then check your answer with mine. So again, 3 steps. First thing we want to do is figure out where is my variable. So when I look at this inequality of b minus 2 is greater than -9, I see that this b is on the left side, all right, and it is being subtracted by 2. So if I came in here and I did my to-do to undo list, all right, I would have that they subtracted b by 2. Which means that I need to do the opposite of subtracting 2, which is to add 2. So the inverse operation of subtraction is addition. So there is my steps to solve. So now I need to go in and I need to actually solve the inequality. So underneath where they were subtracting 2, I'm going to add 2. And then on the other side of the inequality, I also have to add 2. Because whatever I do to one side, I also have to do to the other to keep this equation, or excuse me, this inequality in balance. Well, as we've learned, -2 and +2, those are going to cancel each other out. And so all we're left with is the b. Now we need to bring down our inequality symbol of greater than. And then I've got -9 plus 2. Well, that's 9 bad guys. 2 good guys show up. They battle. Bad guys win because they have more, and they have 7 more. So my simplified inequality when I solve this is b is greater than -7. Well, now I need to go in and I need to actually graph that. So again, I'm going to start with the number -7 here in the middle. That's just nice and easy. And then skipping every other dash, I'm going to count by 2's. So moving towards the right, that would make this -6, -5, -4, -3, -2, -1. And moving towards the left, that would be -8, -9, -10, -11, -12, -13. So there we go. We got a nice labeled graph, easy to see. Numbers are easy to follow on what we're counting by. So now I need to go back and I need to now choose numbers to the left, or a number to the left of -7 and then a number to the right of -7. Plug them in and see which side comes true. So I'm going to start with the one to the left, and I always like to list it on the left side of the number line because that makes it easy when I'm drawing my line because I just draw towards the true inequality. So I'm going to start with -9. I've got -9 is greater than -7. Well, is that true? Is -9 greater than -7? Well, no, it's not. It's actually less than. I have less of them. So that makes that false, which means everything moving to the left of -7 should be false, which should mean that everything to the right would be true. So let's check a number. So -5, let's plug that in. -5 is greater than -7. Well, is that true? Yes, that is true. -5 is greater than -7. So that means that everything moving to the right would satisfy this inequality. So last thing we need to do is actually graph it. So we start with our number that we figured out, which was -7, and we put a circle at it. Then we need to look, is there any portion of an equals to sign that makes this circle filled in? Well, no, there's no portion of an equals to sign, so I do not have a filled in circle. And then I need to draw in my arrow moving towards the true side, which was towards the right. Very good. All right, so when we look at this graph, one thing I just want to point out to you, when it says b is greater than -7, the reason we start at -7 is because that's a starting point. But when it's not filled in, that means it's not actually a solution to this. Because if I plug -7 in here, I'd get -7 is greater than -7, and that's not true. They're equal. So this means that, hey, this is the starting point, and then everything else moving to the right of that would be a solution, which would be true. Any number I put to the right, I could put -6.5 in, and that would be true. I could put -3 in, that would be true as well. So when it's not a filled in circle, it's saying, hey, here's your starting point, but it's not actually a solution. When it's a filled in circle, it's saying, here's your starting point, and it is a solution to this inequality. All right, well, if you flip your paper over, we've got one more example. I'd encourage you to try this one on your own and then check your answer with mine. So example C says m minus 3 is less than or equal to 5. So first thing, find the variable, figure out what's being done to it. It's on the left side and it's being subtracted by 3. So if I came in here and did my to-do to undo list, I would say, all right, m was being subtracted by 3. So in order to undo that, I need to do the inverse operation, which is to add 3. So there is my step to solve this. All right, so now I need to go in and I need to actually solve it. So I need to add 3 under where they were subtracting 3, and I need to add 3 to the other side of the inequality as well, so underneath the 5. Well, then I need to solve it. So as we've talked about, -3 and +3, that's just 0, so they cancel out. And I'm going to bring my m down, because that's all I have left on the left side of the inequality. Then I'm going to bring the inequality symbol down. I've got less than or equal to, and then I've got 5 plus 3, which is 8. Good guys and good guys. So I ended up with m is less than or equal to 8. So now, final step, I need to go in and I need to graph these. So when I go in to graph these, I'm going to start with the number 8, and I'm going to put it in the middle here. It's not the only way to do it, but we got to make sure that number is somewhere on the number line. And then I'm going to count by 2s, skipping every other dash. So 9, 10, 11, 12. And I'm only going to put 2 numbers to that side, and that's fine, which means I need to do 2 numbers to the left. So I'm going to say this one's 7, 6, 5, 4. And that's enough. We can tell with those 5 numbers what we're counting by. It's obvious where those dashes are. So the next thing we need to do is we need to pick a number to the left of 8 and a number to the right and plug them in to see which one is true. So I'm going to choose the number 6 and I'm going to plug that in. So 6 instead of m is less than or equal to 8. Well, 6 is not equal to 8 obviously, but it is less than 8. So that makes this side true, which should mean everything moving to the left of 8 is true. But let's just make sure that nothing to the right of 8 works either. So we're going to plug 10 in, and I'm going to say 10 is less than or equal to 8. Well, is that true? Well, 10 is not equal to 8, and 10 is not less than 8. So that did work out, so this means that is false. So nothing moving to the right of 8 should be a solution. All right, well, last thing I need to do is I need to go back to my number I started with, 8, and I need to draw my circle at it. So there's my circle. Then I need to look for a portion of an equals to sign. Is there one? Yes, there is. So that means this is a filled in circle. And then last thing, I need to draw an arrow to the side that was true, which was moving to the left on the number line. So beginning with 8, which is a solution because it's filled in, everything moving down to the left would also make this inequality true. All right, well, in terms of work, this is what we need to see. The to-do, undo list is optional, but always encouraged. So if you have any additional questions, please let me know, but otherwise you should have what you need to continue on in the chapter.